Today we'll start talking about solutions. It is going to be lecture 17. So what we should know about solutions. Main characteristic of solution is its concentration. Concentration can be expressed in percent, in molarity, or in gram per liter. There are also some other types of concentration. So percent is grams of solute per grams of solution expressed in percent. So when we say it is 5% solution of sodium chloride, it means that we have 5 grams of sodium chloride in each 100 grams of solution. And we can flip this conversion factor. Sometimes we'll use it flipped. We'll use that 100 grams of solution contains 5 grams of sodium chloride. And by mass of solution, we mean mass of solute plus mass of solvent, mostly water. Solvent, mostly water. Molarity is number of moles of solute, in this case sodium chloride, in 1 liter by volume of solution. So sometimes we'll need density to convert mass of solution into volume of solution. And just to remind you that number of moles we can calculate if we divide mass in grams by the molar mass in grams per mole. Now let's start working on these problems. Mass percent of solution containing, so we know mass of solute, which is calcium chloride, and we know volume of solvent of water. But because density equals 1 gram per milliliter, it means that volume in milliliters equals to mass in grams. So it's the same as 196.0 if we multiply it by 1.00 grams of water, which is our solvent. So first thing, we need to calculate mass of solvent, mass of solution. Mass of solution, we should add mass of solute, 4.00 grams of calcium chloride, plus 196.0 grams of water. And we should keep number of decimals, smaller number of decimals, so it is 200.0 grams of solution. Now mass percent is mass of solute, 4.00 grams of solute, divided by the mass of solution times 100%. So it's going to be 2.00%. And we need to keep 3 significant figures because our smaller number contains a smaller number of significant figures is 3. So it is 2% of calcium chloride solution. Reverse problem. We know amount of solute. We know percent concentration. Again, we're assuming that it is density equals 1, and we need to calculate volume probably in milliliters, right? Because we are not asked to convert it into liters or some other unit. So we start with what is given. So this solution should contain 18.0 grams of NaCl. So what this number 1.5% tells us? It tells us that this solution contains 1.5 grams of NaCl in 100 grams of solution. This is our conversion factor. So we have grams of NaCl, which is solute, on the top. So we should flip this conversion factor to get rid of grams of NaCl and get grams of solution. So it should be grams of NaCl on the bottom and 100 grams of solution on the top. And after we divide and multiply, we'll get 1200 grams, and because our density equals 1, so volume equals mass divided by density, grams divided by 1.00 grams over milliliter. So we'll get 1200 milliliters. And we need 3 significant figures. So to get 3 significant figures, we can only convert it into scientific notation. 1.20 times 10 to the third milliliters, or 1.20 liters. So this is our volume. Number 3, we got concentration, percent concentration. We got mass of solution. So this is solute and solvent. And we need to determine mass of solute in this solution. Again, we start with what is given. 200 grams of solution. So vinegar is our solution. And 5% means conversion factor. 5 grams of acetic acid in 100 grams of solution. Grams of solution on the top we started, so we need to use this conversion factor the same way it is written. So 5 grams of acetic acid in 100 grams of solution. Grams of solution and grams of solution cancelled, and we'll get grams of acetic acid, 10 grams of acetic acid. In this case, we need just one significant figure, right? 1, 1. So we keep one significant figure, 10 grams of acetic acid. Number 4. So we need to prepare 10% by mass sodium hydroxide solution, and we need 250 grams of it. 10% by mass means that we should have 10 grams of NaOH in each 100 grams of solution. We need to prepare 250 grams of solution. So to get grams of sodium hydroxide, we need to use this conversion factor in this form. So 10 grams of NaOH in 100 grams of solution. Grams of solution cancelled, and we'll get 25 grams of sodium hydroxide, and we have 4 and 4, so we need 4 significant figures, grams of sodium hydroxide. So we calculated amount of solute, and to prepare this solution we should take 25 grams, exactly 25 grams of sodium hydroxide, put it into some flask and add water to get exactly 250 grams of solution. Now molarity. So we are taking 10 grams of sodium hydroxide and adding water up to 4 liters or 4000 milliliters of solution. So we dilute 10 grams of solute into 4 liters of water, and we assume no volume change, so our volume of solution also is 4 liters. So we know that molarity is number of moles per 1 liter. So we need to convert grams of solute sodium hydroxide into moles. So 10 grams of NaOH, and we know that we are converting to moles, so we should flip this conversion factor. 1 mole of NaOH is 40 grams per mole. So this is 0.25 and 1 more 0, right? Moles of Na or H. We know volume 4 liters, so molarity equals point number of moles divided by the volume in liters. Point 0.06 0.6 0.25 by 4, so it is 6, and then 2.5, right? Moles per liter. 3 significant figures, 3 significant figures. So this is our molarity. Now, next problem, we should determine mass of solute when we know volume in liters and molarity of this solution. So we should start with what is given, 10.00 liters, and we know that each liter of this solution contains 0.05 moles of calcium nitrate. So liters and liters of solution cancelled. Now we have moles of calcium nitrate, and we need it to convert it into grams. We know that 1 mole contains 164 grams of calcium nitrate. So after we multiply, all will get 82.045 grams, and we have 2 significant figures here, so we need to round it to 82 grams of calcium nitrate. Number 7. how many milliliters of 1.1 moles per liter sodium hydroxide solution contain this number of moles of sodium hydroxide. Again, we are starting with what is given, 2.2 moles of NaOH. What do we know about this solution? Molarity 1.1 moles means that we have 1.1 moles of NaOH in 1 liter of solution. So moles and moles, we should cancel moles, so we should flip this conversion factor. We know that 1 liter of this solution, and we consider liter as an exact, 1 liter as an exact number, contains 1.100 moles of NaOH. So now we have liters of solution and we need to convert it to milliliters. Moles and moles cancelled, liters and liters cancelled, and we'll get milliliters, and it's going to be 2000 milliliters, and we need 3 significant figures. To express 2000 milliliters with 3 significant figures, the only way is to use scientific notation. Number 8. The same, right? The same solution, 1.1 moles of NaOH in 1 liter. And now we have 4 grams of sodium hydroxide. We know not number of moles, but number of grams. We know it's molar mass, so we should start with converting grams into moles. Now we have moles of sodium hydroxide. We know conversion factor, right? So moles of sodium hydroxide again should go to the bottom. Moles of NaOH in 1 liter of solution, and again 1 liter is still 1000 milliliters. So first we converted grams into moles, then we cancelled moles using our molarity as conversion factor, and then we converted liters into milliliters. So after we calculate it all, we'll get 90.9 milliliters of solution. And 3 sig figs, and we have 3 significant figures here. And final problem, saturated solution of magnesium phosphate contains this number of moles per liter of phosphate ions, not of the whole compound, but only phosphate ions. We need to calculate molarity of solution. So let's figure out what does it mean. We know that this is practically insoluble. That's why this number is so small, 10 to the negative 6. But we still can trace some concentration of phosphate ions and magnesium ions in our solution. And this solution, if we balance this dissociation reaction, it should be 3 moles of magnesium ions and 2 moles of phosphate ions, right, per each. dissolved mole of magnesium phosphate. So if this concentration is 2 moles will give us 1 mole and 3 moles of this. And we have 7.086 times 10 to the negative 6 moles per liter of phosphate ion, meaning that molarity of the whole compound should be what? Half of it, right? So we should divide 7.086 times 10 to the negative 6 divide by 2 and we'll get 3.543 times 10 to the negative 6 moles per liter. We can come to the same conclusion in a little bit different way. So we start with what is given, 7.086 times 10 to the negative 6 moles PO4 3 minus per liter. Now we know that 1 mole of magnesium phosphate contains 2 moles of phosphate ions. So the same way we get the same ratio, 1 to 2. And it will give us, of course, the same number, 3.543 times 10 to the negative 6 moles per liter of magnesium phosphate. Now we need to convert it into grams, and we need 200 liters. So this is per 1 liter, we need 200 liters. So 200 liters we need to multiply by molarity times 3.543 times 10 to the negative 6 moles per liter, and we need to calculate, actually molar mass is given, we need to use its molar mass to convert it into grams. So 1 mole, and this number is given, 4.407.0 grams per mole. And we can calculate that we need just 0.288 grams of this salt, right? And we used molar mass of this salt hydrate. So we need to measure exactly 0.288 grams of this salt, put it into some flask and dilute it. It should be a really big flask or container, and add 200 liters to get this solution. And this is also magnesium phosphate, but now it is hydrate times 8H2O.